Hey guys, so today's lesson is our last lesson of the circle geometry unit. We're going to be going over how to solve problems with tangent lines, which we have already briefly talked about. So we're going to start, like we normally do, with some definitions. So a secant is a line that intersects the edge of a circle at 2 points. So essentially it cuts through a circle, but it keeps going. The part of the secant that is inside the circle is the chord. And then a tangent, we already do have this definition, but just to remind you, a tangent is a line that is outside of the circle and hits the edge of the circle at 1 point. That 1 point where the tangent line hits the edge of the circle is called the point of tangency. If you draw a radius from the center of the circle to the point of tangency, then the radius will be perpendicular to the tangent line. And that is an important rule to remember. So what do these all look like? So here we have a secant that you can see goes right through both sides of the circle. This inner part here, just from this point to this point, would be a chord. So a chord can exist within a secant. And then this red line down here is our tangent line. It is completely outside the circle, just hits the edge of the circle at 1 point, which is the point of tangency. And then if I draw a radius from the center of the circle to the point of tangency, it will hit the tangent line at 90 degrees. If you have two tangents that meet at 1 point outside of the circle, which is called the external point, then the length of the tangent from the point of tangency to the external point will be the same. What that means is if we look at this second example over here, I have a tangent line right here. I have another tangent line right here. They are meeting at an external point. And so the length of the tangent from the point of tangency to the external point will be the same for both of these tangent lines. Okay, so these are kind of the first 3 steps to solving a tangent problem. Assuming you already have a circle and a tangent line drawn, you want to draw the radius from the center of the circle to the point of tangency and then mark it as 90 degrees, so with like a little box. Then you're going to draw a line from the external point to the center of the circle. This is going to complete a right triangle for you to use. And then you're going to solve for the unknown side of the triangle using Pythagorean theorem. There are other steps that may need to come after that, depending on what you're asked for, but we'll go over that in some of these examples. Okay, so the first example that we're going to do has a circle with a radius of 4 centimeters. It also tells us that the external point is 14 centimeters from the center of the circle. It's asking us to determine the length of the tangent line from the external point to the point of tangency. So to do this, we are, of course, going to start by drawing our circle. Then I'm going to start drawing in my tangent line, and then my radius, and then the line from the external point to the center of the circle. So let's start with a tangent line. And you can draw this tangent line wherever you want. It could be down here, it could be up here, it could go this way. Doesn't matter where your tangent line is, as long as it's outside the circle and hits the circle at 1 point. So I'm going to draw mine like that. With my point of tangency being right there. Then I'm going to draw my radius in. So of course my radius is going to go from the center of the circle to the point of tangency, like so. And then lastly, I'm going to draw from the external point to my the center of my circle. Now, I mean, technically to do this, I should have 2 points, 2 tangent lines that are meeting at an external point so I can tell exactly where it is. You're only actually going to need one of these tangent lines, but I'll draw them both in just for completion's sake. So this is my external point then. And there's my right triangle. I could have another one down here if I wanted. Okay, so now we are going to solve this. I have that length is 4, that's my radius. This entire black line here is 14. That is my distance from the external point to the center of the circle. And it is asking me to find this unknown length right here. Now, the one thing I want you to remember is where to put your right angle. Most common mistake with tangent problems is people putting the right angle in the center of the circle right here. You will never have a right angle at the center of your circle. It must be where the radius meets the tangent line. So that's really important when we're figuring out how to plug these numbers into Pythagorean theorem. So a squared plus b squared equals c squared. Whichever side is across from our right angle, that needs to be our c value. So we're going to plug the 14 in for c, and then with a and b, it doesn't matter which of those I plug in as the 4 and which one is my unknown. Then I'm going to move the 4 squared to the other side by subtracting to get the x squared by itself. 14 squared minus 4 squared, oh, I accidentally added them, is 180. And then, of course, I just need to square root in order to get the x by itself. And your final answer would be 13.4 centimeters. Okay, last example here. This time I have given you a diagram and I have asked how far is the external point from the top of the circle. So a couple things we need to do with this diagram. We need to draw in our radius in the proper location. We also have to draw a line from our external point to the center of the circle. So I'm going to start by doing that. So there's that line there. And then you can see that they have a radius drawn in at the bottom here and it's labeled as 5, but it's not in a position that is useful to us. So we must redraw that radius from the center to the point of tangency, where we can actually use it to create a right triangle. Remember, our 90-degree angle goes at the point of tangency, not at the center of our circle. And then we have here that the tangent line from the point of tangency to our external point is 9, whatever units these are. So the first thing that we're going to do is, of course, Pythagorean theorem. So a squared plus b squared equals c squared. This time, our missing side of this right triangle is our hypotenuse. So it's our c squared that we'll be looking for. So we just do 9 squared plus 5 squared, which is 106. And then, of course, we need to square root it in order to get c by itself. And we get about 10.3 as our c value. Now, that is not going to be our final answer because we just found the length of this entire red line from the external point to the point at the center of the circle. However, it has asked us for the distance from the external point to the top of the circle. So it actually only wants that distance right there. Most common mistake people make here is just taking the 10.3 and dividing it by 2, thinking that these distances would be the same as each other. However, they're not necessarily going to be the exact same, though they might be close. So in this case, what you need to remember is that from the center of the circle to the edge of the circle is a radius. So this distance right here must be 5. And so in order to solve this, all we do is take the length of the entire line, which is 10.3, subtract the 5 at the bottom, and whatever remains must be the top part of that line. So step 2 is 10.3 minus 5, which gives us, as our x value, 5.3. So once again, just like when we were doing chord properties, use the radius if you're looking for just part of a line. Okay, that's it for today's lesson.